Hello, my 12th standard warriors. Time to talk about atomic structure, the lecture 3 of modern physics, and we are going to discuss the history of atoms in brief. But the main part of today's lecture is going to be around the Bohr's model of atom. A lot of questions which will come up in JEE Mains as well as JEE Advanced. Oh, very easy, but important topic from JEE aspect. So all of this in your favorite Pathfinder series with me, and welcome Ankit, hi Kartikeya, VIP, Nevali, hello Akash, hi Blessy, hi Subramaniam, welcome everyone. So you are watching the Pathfinder series, which is the dedicated lecture series for the 12th standard and the dropper students, long-term batch, free on YouTube. I have started Pathfinder series last year, and we started right from electrostatics, and we have almost reached the end of the Pathfinder. By next week, your 12th standard syllabus in detail is over. We're going to go to more revisions and many more interesting sessions. So what are we going to do today? We are going to see in this lecture the brief models of atoms given by various scientists before Bohr. The main theme of today's, or the central theme of today's lecture, will be around Bohr's model. Then we'll go to Rydberg's constant, emission spectra, absorption spectra, and then we are also going to see the limitations of Bohr model towards the end. So all of this with your master teacher, with your captain, with your navigator Shreyas. Nice to see all of you, and happy Vasant Panchami. Yes, Akash, we're going to go to semiconductors as well, and I hope you guys are doing well. I hope you guys are safe. I hope you guys are all excited, and I can see all your chats. Hello Pavni, hello Vijayagiri, hi Tamil Selvan, hello Money Decent, and I can see Akash has already shifted to the Enthuse logo, including Ankit. So guys, you know what? You can also change your display picture. You can change it in support of your only dedicated English medium channel in this country, which is Enthuse. So go ahead, show your support, download the picture which is there in the description box, go to your YouTube account and change it. It means a lot. Hello, A Manu, hello Vedant. Lots of people are new also out here. The weightage of this chapter, I would say at least one question in JEE Main, so 4 marks around. Okay, sometimes they might combine it with some other chapter as well. So it could be a mixture of 2 questions, maybe with X-ray, or sometimes even with photons, wave particle duality, you don't know. So I would say 1 question, give or take. So thank you for smashing that like button and hitting the subscribe button for all those of you who are already our free members. So go ahead, if you have not yet joined Enthuse, right, by clicking those 2 lovely icons at the bottom of the screen. Hello Muhammad Anas, hello Harita, welcome, join in Bachalog. Hi Lokanini, nice to see you all. So are you guys ready for starting atomic structure? Stay till the end. Lots of questions, lots of theory pointers, and all of this will help you get that 4 marks in your JEE examination. So let's begin with a simple question in front of you. So we all know what's an atom. It's like one of the smallest particle, not technically the smallest, but it's one of the smallest particle without dividing the charges. As in, if you divide the atom, then you have to separate the proton or separate the electrons, which are all charged particles. So it's that smallest particle which you can get from a body or a matter without separating those fundamental charged particles. So how many of you know who invented the electron, who discovered the proton, who discovered the neutron, who discovered the electron? Yep. So let's see. Yes, atomic physics is there in physics and chemistry. So in chemistry also it comes. That means 4 marks in chem, 4 marks in physics, 8 marks. 8 marks means couple of thousand ranks ahead in JEE Mains. So that's a huge thing. So 1 stone, you kill 2 birds. It's Sai Venkat, 11 JEE. The way to join the crash course is very simple. There is a link which is there in the description box. Go ahead, click that link, you will be able to join it. Just select which batch you want to join. Both the batches are in English only. Depending on when you want to end the course, accordingly you can join it. Alright. So like I said, Venu Vardhan, 1 question in physics at least. Sometimes even 1 question in chemistry. So 2 questions together. So some of you know it. Very good, Vijayagiri. J.J. Thompson discovered electron. Okay, and he won Nobel Prize for that too. And Rutherford, he was the one who discovered proton with his famous, scattering experiment. And then we had Chadwick, who discovered the neutron. Again, he won the Nobel Prize for discovering that fundamental particle. Yep. Yes, Sudarshan Reddy Palle, I'm doing modern physics in detail. In fact, this is the third class. The first two classes were already done on photoelectric effect, photons, wave particle duality. Next class on X-rays. Next class on nuclear physics. So detailed classes, and after that semiconductor and communication systems, obviously. So remember, last year we had thousands of students just from Vedantu studying online. Just, at the fingertips, they used to watch the lectures, solve the papers, solve the assignments, and through our dedicated membership, they have cracked JEE. We are really thrilled and we are really proud of all these students who have, passed out with amazing marks, amazing ranks, and got into their dream colleges. So now it's your turn to enter into your dream college. And all of these students had, few basic qualities which I'm pretty sure you too can develop. One, they had faith. Two, they had dedication and passion towards, the subject or cracking JEE. Three, they were willing to put in that hard work. That's it. So when you have these three qualities, definitely you can also crack JEE. And obviously, you need the right mentor with whom you can have the faith. You need to have the right system and you need to have the right books so that you can put in your hard work in the right direction. So make sure you make the best use of the courses which are not just offered freely on YouTube, but also the ones which are paid on the Vedantu platform so that your marks can improve. There are lots of links in the description box. Check it out. They are all available on offers using my coupon code SHHPRO. Now, going to the brief history of atom, let's make this quick, not more than 5-10 minutes. Okay, let's do this. Yes, this is the lecture 3 detailed course on modern physics, Sudarshan Reddy. Now, IGT, I'll be doing a motivational session on Monday. Watch it. You will understand how to get 180 marks. Thompson model was all about watermelon. So the moment you think about Thompson, you should think about Thompson sitting on a watermelon. And watermelon, what is it? It's red with some seeds. Seeds were the, electrons, and basically the red part was the positive charge. That's what Thompson believed an atom is made of. He thought that, there are, seed-like things which are the electrons, and the red thing is like the positive charge. That's what, Thompson believed. It is also called as the pudding model of an atom. But we know atom is not like this, but this is how he believed it to be. But the problem with the Thompson's model, although he said that the total positive charge was negative charge, and these electrons are small, and these electrons, why did he assume that the red part is positive and the seeds are negative? Reason was he knew and he had the idea of current electricity. So he thought when electricity is flowing through wires or conductors, these seeds or these electrons are the ones which get easily flown from one part to the other inside the conductor. So the big bulky part, which is the red part, should be positive, and the free moving part should be the electrons, which can be easily knocked off. But although this was fair enough to explain the conduction of electricity or even explain the fact that atom is electrically neutral, it couldn't explain few things like, for example, it could not explain how do you get the hydrogen spectra or any spectra for any particular element. It could not even explain, how alpha rays were scattered by the famous, Rutherford's experiment. So what happened is, after these limitations of Thompson's model, you had Rutherford, who had conducted this very famous experiment, which is the alpha ray scattering experiment via, thin metallic sheet. He saw when alpha rays were projected on a thin metallic sheet, most of the rays went through the sheet. Very few rays got deviated, but very few rays got deflected completely back. You would have seen this back in chemistry as well. This is how it looks like. These are alpha rays. You can see there is a detector over here. There is a metallic sheet. Most of the alpha rays are hitting over here. Very few are getting deflected left or right. very few will be hitting backwards. This clearly stated that most of the atom will be empty. That's the reason why the alpha ray beam is going on to the other side. There is probably a very small concentrated charge at the center of the atom. That's why when alpha rays, which are positively charged, they hit the central part which is positive, they get deflected completely. So that's how Rutherford concluded that the atom is mostly empty, but there is a small bit which is positive. That's what he called as the nucleus, and that's why the alpha rays got deflected if they came very close to that small part which is positively charged. So that's what he thought it to be. And this was good enough explanation, much better than Thompson's model, but still this model of Rutherford, did not satisfy so many other observations. Hello Dakshin, thank you for all the hearts. Sai, nobody knows when the JEE exam will be. Yes Ankit, it will completely reflect back. Okay, so although it explained in detail what could be the size of the nucleus, what could be the spacing in the nucleus, how the electrons are away from the nucleus, and they are probably going in orbits, or probably they are just circling around the nucleus, not orbits, they are just circling around the nucleus because of the electrostatic force between them. It could not explain certain things like, again, the atomic spectra. It could not explain how Maxwell's radiation does not occur. As in, if you have a charged particle which is accelerating, then within no time it should emit radiation and it should fall inside the nucleus. So it should be very unstable. But we know atoms are very stable. It could not explain the stability of atoms. It could not again explain the spectra of different elements. So there were a lot of limitations again over there. Hi Shobit Gangawat. So that's when Bohrs model came in. Before going to Bohrs model, two simple questions just to boost up your energy. Are you guys ready? And if you guys are ready, post up the answer in the chat box right now. Which of the following is not a part of J.J. Thomson's atomic model? Which of the following is not a part of J.J. Thomson's atomic model? Atoms have embedded negatively charged electrons. Atom is a gel of positive charge. Electrons help in conduction of electricity. Atom is a hollow sphere. Interesting. J.J. Thomson's model, which of the following is not a part of his hypothesis? Come on, very easy. I'm waiting for all your answers in the chat box. Remember, only when you put it up in the chat box will I be encouraged to conduct more classes, will I be encouraged to conduct more quizzes, and you too will feel like competing with the real warriors out there. Selva saying, see, very good. Don't worry if you're wrong, whether you are correct doesn't really matter. It shows that you are willing to try. Come on, let's try it out. Are you sure, guys? Okay, Ankit saying B, some of you are saying C. Well, I think you guys are wrong. Yes, it is actually D. Atom is hollow. Oops. See, sometimes simple questions can also play around with you. No, atom is a gel of positive charge. That's perfect. Gel, pudding, red part. Remember, I just told you about this. So the red part in that watermelon is nothing but the positive charge. And electrons help in conduction. Yes, those seeds are nothing but electrons. I just showed it to you in the Thompson's model. Look at this right over here. You can see it. Electrons are the seeds. The red part is the positive. Gel means like the toothpaste or your gum. All right, it's a gel, semi-solid kind of a thing. So that's a gel. So yes, that was perfect. That's what he thought and believed. And you can see that's the reason why option D is correct. Atom is a hollow sphere. He did not say atom is hollow. In fact, he said it is like solid, semi-solid, whatever, but it is filled with positive and negative charges. Negative charge was a part of that entire watermelon. Understand that. I hope this is clear. Next up, going on your screen. Oh my God, Salva, no problem. Even if you're in 11th, you should still be able to answer because you have studied this in chemistry, bacha. Okay, let's go to the next one. Please get this correct. Okay, try it. Make effort. Sincerely try it. I'm pretty sure you will get it. The Rutherford's alpha particle experiment shows that most of the alpha particles pass through almost unscattered, while some are scattered through large angles. That was alpha scattering experiment by Rutherford. What information does it give about the structure of atom? Atom is hollow. The whole mass of the atom is concentrated in a small center. Nucleus is positively charged. All of the above. Okay. Hello DJ Gamer. Welcome. Is this a chemistry class? CH Pawan. I don't have specs. Number 1. Number 2. I don't have a beard as Wasim sir. Number 3. In the description box, I hope it is written as physics. So, yes, this topic is there both in physics and chem. So many topics like KTG, thermodynamics. There you have it. Photoelectric effect. All of these are there in physics and chemistry. But this is a physics class, bacha, the last chapter of 12th standard. Hello, Nikhil Krishna. Welcome and very good. D for Delhi. And that is definitely correct. That's true. Is it blur? H. Sai Venkat. Please change your resolution to 720p. Your YouTube resolution might have gone down. That often happens. Even if you're watching it recorded, make sure your resolution is set to higher grade because that's what YouTube does often. Yep. All of these are the conclusions of Rutherford scattering experiment. Yep. Because most of them pass through. That means it must be hollow. Because some of them get deflected by a very large angle. That means there is a small part which is positively charged. So all of the above are correct. Very good. D is the correct answer. All right. Okay. Oh my God. Salo Kumar, that is very judgmental. Swollen heads. Okay. I'm pretty sure our chemistry teachers on Enthuse don't have. All right. So here is the next thing. Bohr's model. So Bohr gave a better model. You'll be like, sir, is Bohr's model the final model? Nah, it's not the final model. There are many more models which came after Bohr. But why do we still study Bohr's model even after 100 years? Yes, that's right. Even after 100 years, you study Bohr's model, although it's not the fully complete or foolproof model. Reason is, it gives a fair explanation of many things around us. It explains many phenomena. Although it fails to explain certain things, which we'll talk towards the end, we need to understand those phenomena via theories. And what is science all about? Understand, there is nothing like the truth. You always have theories. You always have some hypothesis. And you believe in that hypothesis because it is supported via certain experiments. You don't know what's the exact final truth. Remember that. That's what science is. And often our formal education fails in that aspect. And we are believed into thinking, oh, whatever is there in the textbook, that's the final truth. That's the ultimatum. That's not true, guys, okay? There are theories. You can come up with a better theory if you can support it with evidence. It's like a courtroom. You have sufficient proof. You can prove it. You can disprove the other theories. That's it. Your theory will be considered valid over the other theories. I hope that's making sense. All right. So, having said that, what is Bohr's model all about? He said, he developed upon Rutherford and he said that yes, atom is empty. Yes, there is a central part which is very small, which is very heavy and it is positively charged. And yes, the negatively charged electrons revolve around the positively charged heavy central part. But he also mentioned that there are certain orbits. There are certain orbits and these orbits carry certain energy. Definite energy, not any energy. An electron cannot revolve in any random orbit. It cannot possess any random energy. It cannot, be around anywhere. There has to be some fixed orbits around which these electrons can move. In only these orbits, called as also stationary orbits, can the electron be stable, the atom can be stable, else the electron will fall inside the nucleus. Atom has irregular boundaries. Yes, Abhishek, that's the reason why I had put up a question few days back. When two surfaces touch, what actually touches? Nothing. It's just a force that you feel. Atom does not have boundary. What do you mean by atom? Now, many textbooks, many students feel, okay, if this is the atom, this is the electron, so then you feel like, okay, this is the boundary of the atom. Not really. The electrons can go even farther than that. because it's all a game of probabilities which you learn later on. So technically speaking, there is no such boundary for an atom, but we feel that there is a boundary because the way it is shown, and usually it's that space where the electrons and the particles of the atom spend most of their time in. So that region is called as the atom. But yes, there is a good chance some particles might just go outside the region. A very teeny-meeny probability is always there. Yes. Okay, great. So he also said that the electrons close to the nucleus have low energy, and as the electrons go far away, they have higher energy. So the first postulates are those principles or the theories, propositions which Bohr made. One of the proposition was that there is a positively charged nucleus, yes, at the center of the atom, around which these electrons revolve in circular orbits, perfectly fine. The necessary centripetal force is provided by the Coulomb's force. Remember, positive negative charges attract, so that force for the circular motion, remember, circular motion needs acceleration needs force. Where will that force come from? Coulomb's force. So that Coulomb force between the electrons and the positive charges produces that necessary acceleration for those orbits. Next, he said that the electron cannot move at any random distance, but only in some definite stationary orbits. Very, very important. This word stationary, non-radiating. The meaning of the word stationary orbits is non-radiating. So only in these orbits will the electron not emit any kind of radiation, and that those orbits have fixed angular momentum. What is that fixed angular momentum? That fixed angular momentum L is nh by 2 pi. This is the angular momentum of any electron revolving around the nucleus. H is your standard Planck's constant, alright, Planck's constant, standard value. Pi is pi, 2 is 2. N is your principal quantum number. It's your principal quantum number. Okay, principal quantum number. Fair enough. And by rotations formulas, L is what? R cross P. P is mv. So it is mrv. So mvr or mrv is nh by 2 pi, where n can be any integer, 1, 2, 3, 4 only. Yes, correcto. Yes, Alva. Very good, IGT. Yes, Narana, it is. It is. How are these things derived? Very interesting question. So what happens is, the derivation comes from this particular concept of standing waves. Now, back in 11th standard, you would have studied standing waves, which is nothing but waves which are traveling in opposite directions, hence the energy gets trapped. That is the definition of standing waves. So standing waves is basically trapped energy. And for an electron, for it to be non-radiating, the matter wave, that means the de Broglie's wavelength, should produce a standing wave so that the energy is trapped, and hence you will have fixed non-radiating energy. That is very, very important. Understand? The matter wave of the electron, matter waves, that de Broglie wavelength. Remember, dual nature of a particle and a wave. So the wave nature of electron should produce a standing wave so that the energy gets trapped and the orbit has a fixed energy. And when you draw any orbit in that way, so let's say like this, okay, maybe a standing wave like that, something like this. I'm just showing some random diagram, guys, something like this. So this is a standing wave of that particular electron, like this, and this is your, let's say, radius, and this is your wavelength. So this is the wavelength of that matter wave, So basically, I don't know whether you can see this. This is wavelength. This is one wavelength, lambda of that particular matter wave. So from this you get it, and you can easily say that there are always integral numbers of wavelength. 1 wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths always. So n times of lambda will be the circumference, which is nothing but 2 pi r, and we all know lambda. What is lambda, guys? Lambda is h by p. That's it. Move this around, so you'll get n h by 2 pi is equal to r into p. What is r into p? It is nothing but L. So L is nh by 2 pi. That's how this is derived. Is that understood? Is laws of motion difficult? Not if you study from your favorite Shreyas sir. Just watch my nurture classes. Trust me, you'll understand. There are some 4 or 5 classes out there. I wish Shreyas sir was my drawing teacher. Shankar, for sure you will get at least 35 marks. Not more than 35 marks also. Because that's what the number of marks I used to get in my drawing. Vanakkam, Nick, vanakkam. All right, is that clear, my bacha log? Let's go ahead. Next, the next postulate is when the electron jumps. The electrons need not stay in those orbits. They can jump. They can get excited. They can become sad, just like human beings. When you get happy, you get excited, you jump. When you become sad, you are like on the ground. You're sad like this. So even electrons have emotions and understand the emotions of it. Okay. So, yes. Now how the de Broglie wavelength is derived? Narayan Datta, very interesting question that was derived by experiments, and that was through, different other phenomena of waves. So the wavelength of, any matter wave was proposed from the momentum of a photon. So that's a different theory. In fact, you can watch one of my classes called as do you really believe in reality? Does reality exist if you do not see it? So the idea of the momentum came from that particular logic which I have explained in that particular lecture. So does reality exist or not if you don't see it? So that's a beautiful lecture you should watch. That's how you'll understand it. Anyways, so Maxi, I don't bacha. Maybe you should be more regular in my sessions. Maybe I'll remember you. Hi Sahil. Sir, how you know this stuff? Bacha, I've been training kids for more than 10-15 years now, and yeah, I wrote my JEE long time back. Anyways, now talking about excitation and de-excitation, very important. Whenever the electrons jump from low to high, they absorb. When they jump from high to low, they release. Very, very important. So when the electron jumps from one orbit to the other orbit, there is one photon which is involved. So keep this in mind. So when it jumps from low energy to high energy, that means it would have absorbed. It would have absorbed. Absorbed what? Absorbed a photon. Very, very important. And it's the same way. If it goes from high to low, then it releases a photon. As simple as that. Very, very crucial. Now that you have understood Bohr's postulates, let's see the 3 simple equations. Yep. Yeah, Nikhil, the derivations are available as micro courses, especially my derivations. All my derivations are available. So let's look at the 3 important parameters. Let's do this quickly because I know you guys are very excited for problems. And are you guys excited for problems? Do let me know in the chat box. Hold on. We need to look at the derivations. Very important from JEE Advanced perspective and higher order problems of JEE Mains. You will see why. Radius of any orbit can be found out using these simple principles. Look at this. This is the central charge. What is Z? Z is the atomic number. So let's put up all these things. So what is Z? Z is basically your atomic number. Okay, E is your charge, obviously. E is your electron charge, which is 1.6 into 10 to the power minus 19 coulomb and all of that. R is your radius. V is your speed. That's an electron orbiting the nucleus. So I want to find the radius of the nth orbit. N here stands for your principal number, principal quantum number. And we know how this n works. For the shell labeled K, the value of n is 1, for L it is 2, KLMN, right? Standard KLMN. So that's how it works. Fair enough. You call these shells as KLMN. I hope everybody knows this. So how do you derive it? It's very simple, guys. Just use your Newton's laws, you will get it. So the force towards the center, the centripetal force will provide the centripetal acceleration. So just say Fc is equal to mass into centripetal acceleration. This force will be the electrostatic force. That means 1 upon 4 pi epsilon naught. Charge 1, charge 2. Charge 1 is Ze, charge 2 is E, divided by R square is M into V square by R. This is equation number 1. And the second equation is L is NH by 2 pi. So therefore MVR is equal to NH by 2 pi. Therefore V is equal to NH by 2 pi. M and R comes over here. That's it. This is your second equation. From second, put the value of V from here to here. That's it. Can you see that? My warriors, this V which you see, substitute it over here, and that's it. You will get the answer. Okay. So substitute V from 2 into 1, and you will get the value of R. Now what does the value of R come out to be? The value of R comes out to be as n square h square epsilon naught. There is also one z below, I suppose 4, and there should be a z over here. Now I think it should be fine. Yep. I hope this is fine, guys. Shall we go ahead? All right. Now, how do you get the velocity? The velocity can be found out after finding the radius. Once you know the radius, let me just write this little bit clearly over here so that when you download the notes, it does not compromise it. So this was your second equation. Now, once you know the radius, you can find the velocity from the second equation because R is known. So I can say from equation number 2, substitute the value of R in it, and that's how you will get the value of velocity. This is also very important. The value of velocity comes out to be 1 by 4 pi epsilon naught 2 pi Ze square by NH. Now, do you need to remember the final values? No. Then what should you remember? I'll tell you that also, but hold on for that. Just hold on for that. Okay? Just hold on for that. Next, energy. This is very, very important. A lot of students make a mistake over here, especially with the signs and that number 2. Very, very important. I'll tell you this. See, energy. So first of all, what we did, we just completed radius, then we completed velocity. The third aspect is energy. Each electron revolving around the nucleus will have two kinds of energy: kinetic energy and potential energy because of electrostatic. Hence, you can find out the total mechanical energy as well. So, how to do that? Yes, Jayant Bhati. As soon as I complete my Pathfinder, I will do some NCERT series as well. Don't worry. Okay, I'll be doing. I know your boards are around the corner. I'll be doing mock tests, everything. Guys, please support me, support the channel, make sure it spreads. I will do everything it takes for you guys to excel in your studies. I just need your support. That's it. Without the support, what are we YouTubers for? We just come here to get the love. That's the only thing I expect from you. And obviously your growth. So, yep, energy of the electron in the nth orbit. How do you find that out? First, find the kinetic energy. Kinetic energy is half mv square. So, where do you get this value of v? Substitute v from your previous slide. That's very important. Then you can also find your potential energy, electrostatic, which is 1 upon 4 pi epsilon naught charge into second charge divided by R. How do you find R? It was also found out from the previous slide. So substitute the value of R again from your previous slides. Correct? I have just derived that for you. Once you substitute that, you will get some expressions, bulky equations over here. Now, all you need to do is add both of them. When you add kinetic and potential, you will get the total mechanical energy. you'll get the total mechanical energy. So E will be K plus U. When you substitute everything, you will finally get this as the answer. Minus me raised to 4 z square by 8 epsilon naught square n square h square. Now, you will be like, sir, these are crazy equations. I cannot remember it. Yes, I know what you guys are thinking. Hold on. Once you get all these expressions, you can check it out even at home. There is one beautiful relationship between all three of them. Very, very important and very, very crucial. Listen in. You will see that the total energy is exactly opposite in sign of kinetic energy. Very, very important. Sign wise, it's exactly opposite. Magnitude, modulus values are same. Number one. Number two, the total energy is actually, or rather 2 times of that energy is actually the potential energy. Very, very important. Again, sign wise they are same. Sign wise they are same. Very, very important. Yes. So total energy is potential energy by 2, or potential energy is twice of the total energy. That's how you need to remember it. Now, do you remember this same thing was also there in gravitation? This is also taught to you in chemistry atomic structure. So this relationship is very, very important. And when I say it, I mean it. Yeah, for physics, H.C. Verma and D.C. Pandey. That's very good books. Now, once you remember this, I'll tell you what else you need to remember. You don't have to remember this crazy bulky equation, nor this, nor this. But what you should remember is what it is proportional to. Which variables are important? Let me show that to you over here. Look at this carefully, my warriors. Look at this slide. These are the values that you should remember. Keep this in mind. Radius is proportional to n square by z. So what is a radius proportional to? Radius is proportional to n square by z. That's what you need to remember. That constant is 0.529 Armstrongs. Armstrong is 10 to the power minus 10. This is something you should remember. Now think, if you put n as 1, z as 1, that's for the first orbit of hydrogen. This is the radius. This is the radius of the ground state electron of hydrogen atom. Does that make sense to you? 0.529 Armstrong. Yep, IGT, it was there in gravitation too. Now, the next thing that you need to remember is the value of the speed of that electron in that orbit. It is proportional to, velocity is proportional to z by n. Very, very important. Proportional to z by n, and 2.2 into 10 to the power 6 is that constant, which is obviously the speed of electron in the ground state for hydrogen atom. Because if z is 1, n is 1, that's it. That's hydrogen in ground state. Okay, so makes sense. That's the value you should remember. Third value, energy of an electron in the nth orbit. Oops, there was a minus sign too. Let me put it right over here. Yeah, this is very, very important again. So the energy is proportional to z square by n square. That's in electron volt. Why electron volt? Why not joules? Because these energies are extremely teeny meeny. If you talk in joules, it will be in 10 raised to minus a big number. So it's very, very difficult to handle the small numbers like that. So that's why we change the units to electron volt. And minus sign is also very important. 13.6. What's 13.6? 13.6. Can you see it over here? What is it? 13.6 negative is your yes, it's your negative. That 13.6 is nothing but your ground state energy of your hydrogen atom. Ground state energy of your hydrogen atom. Very, very important. You should remember this. In fact, I'll mark it right over here. Okay, so this is basically your ground state energy for a hydrogen atom. Keep this in mind. Clear, my warriors? Fair enough. Now, these are the things, proportionalities that you have to keep in mind. R is proportional to n square by z, velocity proportional to z by n, energy proportional to z square by n square. Apart from that, this is the chart which you should remember. This chart. It's very important, trust me on this. First, ground state is 13.6. Higher energy, second orbit, minus 3.4. Just remember 3.4 and 1.51, that's enough. You don't have to remember all those values because it will come in handy, that's it. So 13.6, 3.4, 1.51. 13.6, 3.4, 1.51. Keep this in mind. The next energies are going to be, even smaller, minus wise, but don't need to remember it. It's okay. You can just derive it by substituting the values right over here. Notice one more thing. The spacing continuously reduces. The spacing reduces continuously. And when n tends to infinity, that means this denominator becomes very large. N tends to infinity means what? The electron is outside the atom. So that energy is assumed to be 0. Do you see that? 0. It's 0. I hope this is clear. Yep. This is very, very important. This is very, very important. Understood, my warriors? So when it is pulled outside the atom, n tends to infinity, and that is basically your 0 energy level. So if I ask you to ionize a ground state hydrogen atom, what amount of energy is needed? You should think about it like this. You should remember this chart. And then you should think, oh, ground state energy is minus 13.6. To push it outside the atom, to ionize it. To ionize means chuck that electron out. That means n tends to infinity. You need to give it plus 13.6 so that it is pushed outside the atom. Hence, the ionization energy is 13.6 for a ground state hydrogen atom. Is that making sense? Why there is no gravity? There is gravity, Jayant, but it is so small that you can often neglect it. I hope this is clear. Is that clear, my warriors? Very good. Hi Pratiksha, join in. Yep. Shall we go ahead? Yes, this chapter is easy, Narayana, because you have already studied this in chemistry, so you have some idea. So let's solve some questions coming up on your screen now. Yep. Electron of a hydrogen atom revolves around the proton in a circuit. Actually, this should be orbit. Why the hell is it circuit? Okay. Nth of radius this much with a speed this much. The current to the circulating charge is proportional to which power of the electron charge? Let's see. Anish, you are late. You missed some fun part at the start, but it's okay. Join in. Why are the scientists not so well known? Tamil, they are known. It's just that it is not there in your books, because for the syllabus to change, it takes a long time. So maybe after 50, 60, 70 years, whatever the scientists are discovering now, that will come in the textbook once it finds some application, once the syllabus also changes. Also understand the level of the students will also have to continuously change. Obviously, 50, 60 years back, they did not study all these things. So the syllabus also changes. So it takes some time. It will take 100 years for these things to come in the actual syllabus of 11th and 12th. Hello Savarine, Marshall, join in. Okay, so what is the question? The current in the circulating charge. So first of all, let me show you that circulating charge right over here. This is that charge which is circulating like this. There is this radius r, and to complete it, so the time period is basically t. Fair enough. So because it is circulating, obviously I would say there is some current, but since technically speaking it's an electron or a negative charge, so the current will be exactly opposite. So this is the current. By definition, the current is how much charge is flowing upon the time taken for it to flow. That's the definition of the current. So let's go by that and see what do we get. How much charge flows? How much charge flows in how much time? Obviously, the charge E flows, E coulombs flow in a time of t. But I don't know t, so here is what I'll do. E divided by time. Time is distance or circumference, which is 2 pi r divided by velocity. Make sense? Time is distance by speed. So rearranging it further, E divided by 2 pi, you will have V by R. Now notice the radius is that, the velocity or speed is this much. So it will become E by 2 pi. Now in the velocity equation, all these numbers are constants. Just ignore that because I just need the power of E. So I can just say it is some constant into E square. I hope you can see that, some constant into E square. And for radius, all these are constants except E square in the bottom. So it's just some another constant 2, let's say, divided by E square. So all these things, constant, 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 will finally become another constant, and you will have E into E square, which is nothing but constant into E raised to 5. So basically the current is proportional to E raised to 5, which is option C, I believe. Yes, Chandan, it is C. SEA, SEE, CE, C, whatever you want to call it. Hello Ajmal Aju. Will I teach communication? Obviously, Jay. Definitely, I'll be teaching it. I think I should post up the entire schedule for the next week so that you guys feel very happy about it. The syllabus is getting over. Yes, IGT, I'll be doing that, like I said, on Monday. Yeah, that's the correct answer. Moving to the next one. Akash, there is no derivation course of mine for 12th standard, but I have covered a numerical course for 12th standard. And when you join, if you are a part of Vedantu Pro, the teachers would have already derived most of the things required for 12th standard. Okay, so that's what it is. Oh my God, Kirito, such a long time. Paticho text, hi baby Luffy world, reporting on duty. Nice to see you. How's your Vedantu Pro going? I hope you are doing well. I hope the revision is going great. All right, all right. So yes, on the platform it's there for 11th, conducted by me. Yes, Jayant. So when a hydrogen atom is raised from the ground state to excited state, what do you think happens? What do you think happens? Okay. Wow, UV, you are in class 8th, bacha. Okay, you should say high five to Gokulnath if he's around. Yeah, we have a lot of 8th standard and 9th standard kids, and it makes my day, trust me. And one thing, UV and Gokulnath and all 8th and 9th standard kids, all those kids who were always associated with me from 8th or 9th standard, I have seen them doing really well. I don't know whether it's my good luck charm or I don't know, something. All of them have got below 100, below 200 all India ranks in JEE. Advanced, not mains, advanced. Okay, so I really hope you crack whatever exam you have to, be it Olympiads, be it NEET, be it JEE, be it anything, whatever you want to do. I hope you do extremely well, bacha log. Let's see. Wow, Rakesh, you are in 10th. I'll be seeing you in 11th standard as well very soon. So what happens when a hydrogen is raised from ground to its excited state? Well, that's simple. Recollect. Kinetic energy is negative of the total energy, and total energy is some constant into z square by n square. So if it goes from ground state to excited state, that means the value of n increases. So if n increases, this ratio decreases. So think of it like this, from 0.5, it became 0.2, but there is a minus sign. So technically speaking, hasn't it increased? Technically speaking, think about it, minus 0.2 is more than 0.5 because it's a negative number. So kinetic energy has increased. I hope that makes sense. Similarly, potential energy is nothing but 2 times of the total energy. So it will be nothing but a constant into z square by n square. So if n increases, obviously potential energy should decrease. It's a oh, but there is a problem. See, now this is where you can make some mistakes. Understand this. Okay, before going ahead, actually I'll not even do this. Now, even before going ahead, there is a very interesting catch to this. The interesting catch is that the constant itself is negative. Don't forget that. The constant itself is negative. Remember, it is minus 13.6. So technically speaking, this constant itself being negative, strictly speaking, what should happen? The kinetic energy will be a positive constant into z square by n square. Positive constant into z square by n square. So now you will get the idea. Now you will get the idea. If n increases, kinetic energy will not increase. Kinetic energy will decrease. Understood? Understood? Got it? My warriors? Very good. Jayant, if you have already joined, then there is no chance of getting more scholarship. Alright? Those fees are fixed. Okay. Similarly, now you can attempt for the potential energy. So, potential energy is 2 times of the total energy. So, this will be 2 times of that negative constant into z square by n square. So, it will be basically a negative number into z square by n square. So, now you can guess what should happen. If n increases, this ratio will decrease. It will become less negative. That means value wise it will increase. So potential energy increases. So potential energy increases, kinetic energy decreases. So that should be option A, I believe. Yes, it is A. Can you see that? Understood? Clear? Very good. Yes, yes, very good. That's a very good attitude. Very good attitude. When will modern physics be completed? I hope it should be completed by next week. Next 2 more classes. Okay. What happened, Akshaya Burgan? Not loving modern physics. You want to go back to Newtonian physics, ancient physics. That's what technically it should be called, right? Newtonian physics, ancient physics. Then we should also have some medieval physics. And then we should have modern physics. And then the contemporary physics, God knows, so many other things. All right, moving to the next one. Okay, HI1 I'll have to see because I generally don't end up checking Telegram messages. All right. Okay, Lagrangian physics. Oh my God, UV, that's very good. Keep it up. The radius of electron's second stationary orbit in Bohr atom is r. The radius of the third orbit will be. Interesting, simple, but don't confuse. The radius of the second, that means n is equal to 2, is r. And we all have seen that the radius is directly proportional to n square. Keep this in mind, n square. So, radius of the second orbit upon radius of the third orbit will be 2 square upon 3 square. Because the question is, what is the radius of the third orbit? So therefore, R3 will be, take that over there, it will be R2 into 3 square divided by 2 square. Second orbit's radius is R, 3 square is 9, 2 square is 4. So 9 by 4 is how much? 2.25 R, which is option B. B for Bombay. B, yes, it is option B. Got it? Done. Shall we go ahead? Oh my God, hardest topic in physics, rotational motion. It just rotates in my head. You should make it fluidic. You should make it like fluids by watching my classes of nurture series. Trust me on that. Watch my numerical course, watch my derivation course, watch my Sharma course. You'll get a hang of it. Okay. What are my expectations, Rajat? I have given up on every official now. It's like it's high time now. I mean, every teacher in the country, every institute is now fed up. Like, when are they announcing the dates? Do they even remember that there is a 12th standard, or will they just announce for the next 11th to 12th moving students, this is the JEE Mains dates? Or will you be like the auto droppers batch, like you'll be giving exams with the, the next year's 12th standard? I don't know what they are doing, what you guys are going to do, what is that we should expect. At least give us some tentative, timeline, some number of attempts. Nothing, nobody knows. Everybody is making random videos out there on YouTube. It will be now, it will be then. I got to know from some secretive sources that this guy, this official met this education minister and they were discussing something and he was just doing like this, so most likely there will be 2 attempts. And then I don't know, people are creating some random rumors, guys, so please don't believe them. Yeah, just wait for it, just study with me, that's all. Okay, whatever they have to do, let them do. Omicron wave also ended. I predicted 1 month back. I told you, I showed you the charts, those nice bell curves I showed you. Omicron wave will end by January end or February first week. And by February end, it would be gone completely. It would be out of your heads. What to do now? Yeah. All right. Okay. So moving to the hydrogen spectrum. What is this hydrogen spectrum? Everybody has a signature, right? So what's my signature? Okay, this is my signature. This is my signature. Look at this. This is my signature. Not many of you know this. Right? This is my signature. Now please don't take a photocopy of this and post it somewhere or sign some blank checks. Please don't do that. Now every atom has a signature. Right? Every atom has a signature. And that can be obtained by 2 ways. One is called as absorption spectrum. Second is called as a emission spectrum. And each atom has a unique spectrum, unique signature. Looking at the signature, you'll be like, hey, this is the signature of hydrogen. Hey, this is the signature of lithium. Hey, this is the signature of iron. You can just look at the signature and you can guess what the atom is. Everything is unique. Look at this. This is the absorption spectrum. Absorption, meaning it takes away. Look at this. You can see something missing. Some lines missing. Can you see that? Yep. Oh my God. My signature just got leaked. I'm so worried. I should be very careful about my checkbook now. Guys, please don't withdraw anything from my bank account. Yeah, it's bad. I mean, I'll be left with nothing. Yeah. Okay. I should really secure it now. Okay. So what do we need to do? See, understand what an absorption spectrum is. What an absorption spectrum is. When you pass all the wavelengths or a variety of wavelengths through an element, then that element will absorb few of the colors, few of the wavelengths, and the remaining ones will just pass through those elements. I'll repeat. Look at this. I'll just draw it over here, maybe. You have light of all possible wavelengths. All possible wavelengths. Okay, all possible wavelengths. And here you have that element. That element will absorb few of the wavelengths. Some wavelengths will pass through it. Some wavelengths will get absorbed. So whatever you see over here, the bright ones are the ones which get transmitted. The ones which are transmitted right over here. The ones which got eliminated, maybe this one or this one, so those are the ones which are missing. Why did that element absorb it? Very simple. Very simple. See, Aryan, I am just telling you, explaining you right from the beginning, you can see that. What has happened is, atom is made up of nucleus, positive electrons revolving around it. Remember, electrons can get excited and can get de-excited. So, imagine the light which consists of different wavelengths. One of the photon energy is enough to make that electron jump from lower energy to higher energy. It is exactly matching, the photon's energy is matching the energy difference between the two levels of the electron. So the moment it absorbs such a photon, the electron gets excited and the photon is destroyed. So those photons are missing because those electrons are absorbing those photons and getting excited. Each atom has unique energy levels. This energy level diagram, it's not going to look the same. It's not going to look the same. It's going to be different because remember the formula of E, it is Z square by N square. It will look very different. All these lines will be different for each and every element. That's the reason why the jumps are also going to be unique for every element. Is that much clear? Is that much clear, my warriors? So every atom, every element has unique signature because the energy levels are discrete and unique. So the jumps are unique. So when light of different wavelengths, different photons pass through an element, only few of the photons will get absorbed, get destroyed, and that energy will get used up in making those electrons jump from one to the higher orbit. And that's the reason why you will see some colors are missing. Those are the absorption lines. Very good. Is that clear? Is that clear, my warriors? Perfecto. This is called as the absorption spectrum. Now, you can have the exact negative of the absorption spectrum. Exact negative. Whichever is missing, you can make it bright. Whichever is visible, you can make it dark. That is called as the emission spectrum. Exact opposite. How to do that? Simple. What you need to do, you don't need light for that. All you need is a very hot object. Hot. Remember radiation, 11th standard? 11th standard you have learned heat transfer, conduction, convection, radiation. Radiation is what is at play over here. So you have some hot element. That hot element will have atoms with high energy, vibration, rotation, oscillation, everything translational. So when they hit with each other, the electrons get knocked out. Tuck, 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 tuck. Remember, electrons are on the outermost shells, so they get affected the most. The electrons get knocked out. So if the electron is in the lower orbit, it will be pushed by the energy of the collision to a higher orbit. And once the electron gets pushed to a higher orbit, because it has got pushed via collision, the energy of the collisions will reduce, because it takes away that energy in the form of jumping to make those electrons jump from low to high energy. Once the electron jumps, they will be very excited, they'll be very happy, but they can't stay there for long because an atom becomes unstable when it is excited. Remember, no happiness lasts forever. If you become very happy, then you should be really worried. Something sad is going to happen, or maybe this happiness won't last for long. Like it happens after every vacation. You become very happy because exams are over, and before you know it, the next exams are around the corner. So the atom, basically that electron becomes de-excited, and when that electron becomes de-excited, what will happen? A photon will be emitted. Yes, a photon will be emitted. So this hot body will emit photons when the electrons jump from high to low, high to low, high to low, back to its ground state. Understood, my warriors? Yes, I have taught heat transfer in Nurture series, Jay. No, Narayan, Pathfinder is just the name. Don't get carried away by that name as the Pathfinder book. How many types does the spectrum have? There are two types, Vandana. One is absorption, one is emission. So this spectrum is exactly negative of the previous one. Reason? See, in absorption, whatever light or whatever photon gets absorbed to knock out that electron to a higher energy state, when the electron comes back, then exact same photon will be emitted. So hence, the emission spectrum is exact negative of the absorption spectrum. Alright, lines is basically these lines which are missing. That's why it's called as a line spectrum also. Okay, everybody clear about this? Very, very important. So emission spectrum occurs by thermal energy. You need thermal energy. You need to make that element hot so that it jumps, collides, excites the electron and de-excites. Once the de-excitation happens, that's when you get the emission spectrum. Absorption spectrum needs lot of light falling onto it, and that light gets absorbed, and whichever is missing or whichever is less in intensity, that is your signature. Every element will have different lines. That's how you can compare it. Very good. Where do you use it? To identify which element it is. How do you know this is this element, this is that element? That's it. This is the method to determine the element. spectrum. Very interesting, right? Very good. Let's move ahead. So, yeah, let's solve a question. The figure shows the energy levels of P, Q, R, S. P, Q, R, S and G. Okay, I hope you can see it. I hope that's visible right over there. All right. Candle flame is different because of spectrum? Yes, Sridhar Shah. Because each element that is burnt will have different kind of lines, different kind of colors. Definitely. Okay, so a red line, the emission spectrum of the atom can be obtained by the energy level change from Q to S. So it's mentioned Q to S, you get red line. Interesting. So let me just mark it over here. From Q to S, you get a red line. So when the photon jumps from high to low energy, red wavelength is emitted. So a blue line can be obtained for which energy change? Look at the options, you will get an idea. Now if you compare between red and blue, red has a long wavelength. That means the energy of that photon, the energy of the photon is basically less because E is hc by lambda. Make sense? So this energy should be less. But if you look at blue line, the blue color, it has a very short wavelength. That means the energy of that photon is more. If the energy of the photon is more, that means the difference of the energy levels is more. Now we all know as you go from bottom to the top, these lines spacing reduces. I hope you remember the diagram. It was like this, then like this, then like this, then like this, and then like this. The spacing between them, you can see it reducing. So quickly think about it and let me know the answer. Yes, so obviously Aryan, this is there in advance. It is. So think about it. Q to P to Q, no, it's very small. Q to R, that's also small. R to S is also small. R to G, yep, that's the correct answer, I believe. So R to G, so that's a big line right over here. So this is where you will get a blue line. So hence that's the answer. This was in fact asked in JEE Advanced screening paper in a different way. Very interesting question. Option D should be correct. Got it? Let's move on to the next question coming up on your screen. Everybody ready to the next question, guys? Yes, Venkat, the option is D. Alright, Aryan, I hope you are understanding, bacha. This is very, very important topic. Okay, let's go ahead. Okay, so there is an electron which revolves around a nucleus of charge this much. In order to excite the electron from 2 to 3, the energy required is 47.2. Z is equal to how much? Okay, let's try this out. It's not that difficult. Let's do this. Okay, so here we have the nucleus ZE. This is your, let's say, first orbit, then second orbit, and the third orbit. Okay, so what do you have to do? You have to excite the electron from 2 to 3. So you have to take this electron from 2 to 3. So n is equal to 2 to n is equal to 3. In order to do that, okay, you need how much energy? 47.2 electron volt. That means that's the energy difference between the two orbits. So this is basically the energy difference between the orbits of that atom. Find the difference, that's it, you will get it. So what is the energy difference between the orbits? Higher minus lower energy. So E3 is higher minus E2. So E3 will be minus 13.6 electron volt into Z square by N square. N square is 3 minus, remember there is already a minus sign in that. So there will be minus 13.6 into Z square divided by 2 square. I hope that makes sense. N is 3, N is 2. I just substituted, and this formula I just gave it to you some time back. So this will become 47.2. Remember 13.6 is also in electron volt, so you need not convert it into joules, not required. So 13.6 is common, Z square is also common, minus minus becomes plus, so it will be 1 by 2 square minus 1 by 3 square, I suppose. So therefore this will become 13.6 into Z square, and this will become 9, this will become 4, 9 minus 4 is 5, 9 4s are 36, I suppose. So let's just shuffle this equations around a little bit. Z square will become 47.2. So I'll write it as 472 divided by 136. It's one and the same thing. I've just shifted the decimals on both sides. I'm allowed to do that, I think. Okay, so 36 goes on the top and you have 5 below. So what next? Can I cancel out few things? Let's see. I think it will go 8 times maybe. Let's try this out. So if I divide it 8 times, just check this out. Yes. So 5 and okay, 59 I think. Yep, 59. And this one will also go right over here. Can you see that? Yep, 59 guys. Can you see that? Very good. So this will also go 8, yep, 1 and then 7, right? And now I can make some approximations because I can see the numbers over here 3, 4, 5, 2. Approximately 5 goes, this is approximately 5 goes with 59 12 times because 59 is close to 60. So this is roughly 12, roughly. 17 and 36, 17 2s are 34. So it is slightly, 17 goes with 36, slightly more than 2. 12 2s are roughly 24, slightly more than that because this is slightly more than 2, this will be slightly more than 24. So Z square is 24. So obviously Z will be root of approximately 24. It's slightly more than that actually. So which is number 5, I suppose. Yep, is that clear? We will do the calculation. Let it be Aryan. No, I'm just trying to show you how you can do the approximations. I know you guys can do the calculations as well. Sometimes I'm in the mood, I do the calculations also just for you so that you understand how to do it. Great. Very good. Option C is correct. Yep, it is. Got it? How to do the approximations. So you don't have to sit and multiply all these numbers. You can just do approximate because options are already there with you. Okay, let's go to Rydberg and all of that now. Are you guys ready? Very good, Pranav. Very good, Rita. Questions are asked from which are asked from this chapter look simple. Yes, it looks simple. Okay, let's move on then. Can this be asked in mains? Definitely, Anish. It can be. Definitely. Yes. Now, instead of doing all these calculations, sometimes you can avoid these calculations in certain type of questions with the help of the Rydberg's formula. And you should know the name of the series. Remember these lines. When an electron jumps from any shell to n is equal to 1, that means the lowermost shell, n is equal to 1, k shell, those photons which are associated, they are called as your Lyman series. Okay, Lyman series. So Lyman series means the electron jumps from any outer shell to n is equal to 1. That is Lyman. Balmer is from any outer shell to the n is equal to 2 shell. That is called your Balmer series. Then you have the Paschen series, which is from anything else which is higher to n is equal to 3. Then you also have bracket and p fund respectively for 4 and 5. That's it. That's what you should remember. Jagdish, you need not watch it. You watch this now. This is very important because this is the latest series. Okay, so Lyman for 1, Balmer 2, Paschen 3, bracket 4, p fund 5. Just say it in order. You don't have to remember which one is for what. Lyman, Balmer, Paschen, bracket, p fund. That's it. Just say it in order. That's it. It will be there in your head. Now, in order to find the wavelength of the light which is emitted, wavelength of the photon which is emitted, because of the change in the orbits, we will find the Rydberg's formula. It's very simple. So I will say the change in the energy in the orbits, all right, when it goes from high to low, that will give rise to the energy of that photon. And when you substitute the value of the energies, which is, higher minus lower, which is minus 13.6, and then you have z square by n1 square minus again 13.6 z square by n2 square is equal to energy of the photon is hc by lambda. Just play around with this a little bit. You will get z square by z square, and you will have 13.6 also common. 13.6, and then you can write this as minus minus is plus, 1 by n2 square minus 1 by n1 square is equal to h into c by lambda. Take that hc below and you will just get 1 by lambda, okay, 1 by lambda is equal to z square into a constant, and you will have 1 by n2 square minus 1 by n1 square. Now this constant is called as the Rydberg's constant. Okay, this is called as the Rydberg's constant, which is 13.6, but that is in electron volt. You need to convert this also into electron volt and all of that, and this value comes out roughly as 1.1 into 10 to the power minus 7. Okay, so 10 to the power minus 7. Oh, sorry, my bad, 10 to the power 7. Okay, sorry guys, 10 to the power 7. Oops, where did we go? Yeah, 10 to the power 7 per meter. So that is something which you should remember. Okay, clear? Lambda is inversely proportional to the atomic number in Rydberg's formula, right? Lambda is inversely proportional to the atomic numbers square, actually, not atomic number square. Okay, so that is the formula. I just kept it for all of you right over here, just in case you need it. Now some of the books start with n2 first and then n1. Some books go with n1 and then n2. Don't get confused. Always try to make this number positive, that's all. Okay, just try to keep this number positive. Don't have to think, sir, is this higher, this is lower. That is simple maths. You always will try to bring a positive value out here. Fair enough. So I hope this logic is very clear in front of you. Now let's do some questions based on this. Very, very interesting. Hello Keshar Singh. First question coming up on your screen is this. The following diagram indicates the energy levels of a certain atom. Maybe the energy level changes from 2e to e and a photon of wavelength lambda is emitted. The wavelength produced from 4e by 3 to e is how much? Interesting question. So the first part of the question says, when the light is emitted from this transition, the wavelength is lambda. When the light is emitted from this transition, the wavelength is, I don't know, you need to figure this out. So that's simple. Use our standard technique. Difference in the energy levels is the energy of the photon. That's it. So delta E is energy of that photon. So delta E will be 2E minus E will be hc by lambda. Therefore, hc by lambda is equal to just E. Next up, for the second part, the change in the energy is 4 by 3. 4 by 3E minus E is hc by another lambda. I don't know that. So 4 by 3 minus 1 is 1/3. So 1/3 E is equal to hc by lambda. Now E is hc by lambda. So just take this value and substitute it over here. So see what you get. You will get 1 by 3 hc by lambda is equal to hc by lambda 1. hc goes. So what will you get? Lambda 1 is 3 times of lambda. So do I have an option like that? Maybe. Yes, I have. Option D. No, Venkat, it is not A, bacha. No, Ankit, it is option D. Alright. So let me just change the AC temperature a little bit. Looks like it's not adjusted properly. Just 1 second, guys. Okay. Alright, let's move to the next question. Yes, 3 lambda is the answer. Next question up on your screen now. The ratio of the frequencies of the long wavelength limits of Lyman and Balmer series of hydrogen spectrum is. Yes, my AC is on, but I've been calling that guy from a long time because it does not work sometimes. That's the reason. Okay, so the ratio of the frequencies for the long wavelengths. Let's figure this out. Long wavelengths. When is the wavelength long? Let's try to figure this out. See, if you draw the energy levels, you will understand it. If the wavelength is long, by this formula, delta E is equal to hc by lambda. Lambda is long, change in the energy is less. Very, very important. So, for the Lyman means to 1, n is equal to 1. So the energy difference should be small. The smallest energy difference will be from this orbit to this orbit. So this is your Lyman's longest wavelength. And this is for your Lyman. And for Balmer, remember it should be from something else to n is equal to 2. So this would be for Balmer. Alright. So now just use your formulas and you'll get the answer, guys. So 1 by lambda Lyman will be Z square R. Remember it should be from 2 to 1. N is 2 to 1. So 1 is smaller than 2, but in reciprocal you need to write it reverse. So 1 by 1 square minus 1 by 2 square. Fair enough, which is Z square into R. So 1 minus 1 by 4, which is 3 by 4, I suppose. Just check this out. 1 minus 1 by 4. Yep. So that is 1 by lambda of Lyman. Similarly, 1 by lambda of Balmer will be Z square into R. And then you will have from 3 to 2. So 1 by 3 square minus 1 by 4 square. So this will become Z square R. That's your 1 by lambda of the Balmer series. 1 by 9 minus 1 by 16, right? Oops, I made a mistake, I think. 2 to 3. I'm so sorry, guys. Sorry. This was supposed to be from 3 to 2. So 1 by 2 square minus 1 by 3 square. That's fine. So therefore 1 by lambda of the Balmer will be Z square into R. 2 square is 4, 3 square is 9, 9 minus 4, that's 5, and 9 4s are 36. So that's what you get. So now just divide the two and you should get the answer. Just divide the two. Lambda of Lyman, because that's what is asked. Ratio of Lyman and Balmer. So lambda of Balmer will be, so for Lyman, when you flip it, it will become 4 by 3. It will become 4 by 3. And for Balmer, when you flip the equation, it will become 36 by 5. So check this out. It will become 4 by 3 and you will have 5 and you will have 36 over here. 36 over here. So check this out, guys. Do I have some? Yep, this will be 9 times. So 5 by 27, I suppose. 5 by 27. Just check this out. Yep, it is. It is 5 by 27. Yep, Aniket. Will I get a chance to join Ekalavya? I already enrolled into class 11. Annadurai, you will have Ekalavya chance next year, not this year. Ekalavya is for 12th pass out students, not for 11th or 12th standard students. Yep, that's the answer. Moving to the next question. Raghutanam, I think you have messaged me on Telegram also, Instagram also. Okay, looks like I need to check your message. Raghutanam, it's little bit difficult to find the messages. Can you comment on any of my pictures and say, sir, I have messaged you. That way I'll be able to quickly go to your profile and check out your message. Trust me, some people do that. Okay, moving to the next one. Ready, guys? Okay, what do we have? An electron collides with a fixed hydrogen atom in its ground state. Okay, electron collides with a fixed hydrogen atom in its ground state. The atom gets excited, the electron loses all its energy. Consequently, the atom may emit a photon corresponding to the largest Balmer series wavelength. How much is the energy of the colliding electron? So you often get questions, especially in JEE Advanced or higher order questions of JEE Mains, where you have collision related questions. So let's see how to do this question. Okay, so what do we have over here? Let's first figure out what's happening. So we have an electron which is moving with certain kinetic energy. So I'll just put it over here. And then you also have basically, let's say, an atom. So this is your hydrogen atom in its ground state. So this is your electron in the ground state. This is before. Now what happens is, in the next state, it collides and loses all its kinetic energy. So that means this electron comes to rest. It comes to rest. And the hydrogen atom gets excited. Obviously, it's given in the question. the atom gets excited right over there. So this hydrogen atom, this is your electron's first orbit, and maybe it goes to some higher orbit. So this is excited hydrogen atom. I don't know till which shell it gets excited. I'm just showing some excited state. And once that excited atom comes back to its ground state, you will see a photon will be emitted. And that photon corresponds to the largest wavelength of the Balmer series. So this is lambda max of your Balmer series. Interesting. That's what is happening in the question. Very good. What is ground state? Ground state is the lowest energy state. So for a hydrogen atom, there is only one electron. So that electron, when it is in the lowest energy state, it will be in the first orbit or the K shell. So that's what it is, the ground state, the lowest energy state. Pranav, actually I'm a physics teacher, but I'm teaching a chemistry topic because it's there in modern physics. All right, but I'm so glad that it will also help you in chemistry too, bacha. Okay, moving ahead. Now, once you understand it till here, let's try to frame an equation because this is the visualized scenario. Kinetic energy gets transferred to the electron to excite it, and that same energy goes into energy of photon. That's what you understood. Hence, can I say that the kinetic energy of the electron, goes into energy to excite the hydrogen atom, and that same energy goes into the energy of the photon of the Balmer series, right? That is the same energy of the photon of the Balmer series. So we need to find this out. That means we just need to find this part out. How do you find the energy of the photon of the Balmer series? Think about it. There are many ways of doing that, but the easiest way to do that, what would be the easiest way, my warriors? Think about it. What would be the easiest way? Just use the energy formula. Please don't. Okay, some of you are saying that, sir, we'll use probably the Rydberg's formula. No, you don't need to use the Rydberg's formula. Without that also it will be easy, because I think all the answers are in electron volt. The problem with using Rydberg's formula is it's not like it's wrong, but you will find the wavelength. Once you find the wavelength, then you'll find the energy and convert it into electron volt. So it's like a 2 or 3 step process. I will cut it out in 1 step. I'll tell you how. See, what you need to do is just figure out what do you mean by largest wavelength of Balmer. Largest wavelength of Balmer means shortest energy difference. So energy difference wise it is minimum, and that happens for which to which transition? Lyman-Balmer. So 3 to 2 transition. So all you need to do is energy of 3 minus energy of 2, which is minus 13.6 by n square. So that's 3 square minus 13.6 by 2 square. This is all in electron volt because I want my final answers in electron volt. So 13.6. And there you have minus is plus, so 1 by 2 square, so that's 1 by 4, and this is minus 1 by 9, I guess. So this will be nothing but 13.6 into 9 minus 4, again 5, and the 9 4s are 36. Okay, now let's try to approximate. Just think, what is 13 5s are? 13 5s are 65, right? So 13 5s are 65. 13.6, so the next higher number is 14. 14 5s are 70. Now, if I divide 70 by 35, I will get it as 2. But this is a number which is between 65 and 70, and the number below is almost like close to 35, which is 36. So definitely the answer, when you increase the denominator and reduce the numerator, will be slightly less than 2. Think about it. 70 by 35 is 2, correct? So if I decrease the numerator, 75, make it slightly less, and increase the denominator, that means the answer will be less than 2, correct? So hence, which is the number which is slightly less than 2? 1.9. Very good, Crash Master. Yeah, understood? So that's all you need to do. So that's how you approximate calculations, guys. You cannot sit and calculate. I mean, you can, you'll get the answer, but you don't have that time. And that's what toppers do. They just make some approximations and manipulations. Hi, Steve Joel. Yep, very good. Let's move on to the next question. An electron with kinetic energy E electron volts. What is E? I don't know. Collides with a hydrogen atom in the ground state. The collision is elastic. Wow, what a question. Collision is elastic if. Okay, let's see how many of you can do this. Thank you, everything. Very good, Ramya. Let's see how you can do this question. Elastic collision. What is the meaning of elastic collision? The meaning of elastic is no energy lost in heat, light, deformation, etc. Right? So the kinetic energy before and after is conserved. Interesting. So let's try to picturize this. No point without that. If an electron is moving and let's say you have a hydrogen atom, this is an electron like over here, which is orbiting the nucleus, and let's say the collision is inelastic. Imagine, let's say it's an inelastic collision. That means, you know what will happen? What will happen? Look at it. This hydrogen atom will go into its excited state. So the electron will probably jump. This electron will jump, and this electron, okay, will lose its energy. This electron will have less energy. So where is the energy lost? In some kind of a deformation, technically speaking, because that energy has excited the hydrogen atom, the electron has absorbed that energy into deforming itself to go into the higher energy state. So isn't this like an inelastic collision? Understood? Now, what will an elastic collision look like? Let's try to figure that out. So if this collides elastically, wow, I love this shade, isn't it looking fabulous? If it is an elastic collision, then that hydrogen atom will be unable to accept that energy, okay, will be unable to accept that energy to change it to an excited state. It will remain in ground state, and that electron might just get deflected maybe. So that electron just probably goes somewhere. It has the same energy as before. That's it. So it's an elastic collision, like a ball hitting another ball, and they collide elastically and they just go like that. You would have seen so many problems like this. That's an elastic collision. It was unable to excite it. It's still in the ground state. So it is still in the ground state. This is in the excited state. This is in the excited state. So when can the atom still remain in the ground state? It cannot accept that electron's energy to, go into higher energy states. That's possible if, recollect the energy levels. Recollect the energy levels. This was minus 13.6. Correct? This was minus 13.6. Recollect. I have shown you this energy diagram. Go back. Go back right over here. I've shown you this. Let's go over here. I don't know. Some of you might have joined a little bit late. Yeah. Do you see this? Energy level diagram. Minus 13.6, minus 3.4, minus 1.51. So just think about these numbers and you'll get an idea. Minus 3.4, minus 1.5. So let's go back. Right over here. Just 1 second. Okay, where do we go? Oh, this is also done. Yep. So minus 3.4, minus 1.5, and so on and so forth. Now look at the options. You will see energies like 3.4, 10.2, 13.6, any value. Just imagine that electron has some energy which is unable to push this electron to over here. How much energy is needed to jump from here to here? Just calculate the difference. 13.6 minus 3.4. Just do that. 13.6 minus 3.4. How much is that value? This comes out to be 10.2 electron volt. Now imagine the electron which is colliding does not have 10.2 electron volt energy. How on earth will it make this electron jump over here? How on earth will it make the electron over here jump to its excited state, because it does not even possess 10.2, which is the least energy to make that electron jump to its next excited state or the first excited state. So it's unable to do so. Are you able to understand this? So it looks easy, but it's not so easy when you think about it in detail. Anay Choksi, unfortunately, Vacha, this is a completely English medium channel, so I'll have to use English medium. We have a dedicated Hindi medium channel as well. So for all the students in our country who are learning or studying in English medium, and in in the future also they want to go abroad or something like that, obviously you will be studying only in English medium. Now, does that make sense? So for all the energies less than 10.2 electron volt, the collision will have to be elastic. Does that make sense? Because it will be insufficient. It will lack that energy to push it to the higher state. Yep. I hope this is clear. Yes, for JEE 2, Anay Choksi, I mean, JEE का पेपर भी तो अंग्रेजी में होगा और कुछ लोग हिंदी में भी लिखते हैं, बट काफ़ी लोग अंग्रेजी में लिखेंगे एंड अंग्रेजी मीडियम में पढ़ रहे होंगे, और आगे जाके भी जब आप बाहर जाओगे, है ना, you will need English for jobs and higher studies. So obviously you will be studying in English. That's why. Yeah. So let's see why Bohr's model failed in the end. So all this was good till now. So Bohr's model failed because all of this was fine for smaller atomic numbers, but the moment you go to higher atomic numbers, then you will see that the value of the radius and the energy which you calculate, that values come out to be slightly different, number one. So even for hydrogen atom, when you do detailed calculation, the values are slightly different from what Bohr calculated. But so Bohr's model is valid for very small atomic numbers. Number two, there is something called a Zeeman effect, where the spectral lines also split, and that splitting of spectral lines could not be explained by Bohr. Not just that, Heisenberg predicted, and he told correctly, that you cannot locate the position and the momentum of a particle simultaneously. But if you realize, in our equations we have predicted the radius, that's the position, number two, the velocity, which is the momentum indirectly, both of them together. So that's not possible because of the uncertainty principle, and that's what Bohr's model failed to oblige. And that's the reason why Bohr's model is not so accurate in the long run. And there are other models, the molecular orbital theory, the orbital theory, and so on and so forth, where you talk about electron as a probability cloud. So what many people think is the atom looks like this, because that's what has been told to you in your books, or that's what your mental picture is about an atom right from your childhood. This is how an atom looks like. But actually speaking, the atom is not like that. It's more like a cloud, of electrons. Okay, I don't know why the picture did not load, but yes, it's more like a cloud of electrons. There is all probability. There are wave functions around the nucleus which just tell you where an electron might just be, but even if you locate it somehow, you don't know what its velocity is. It's crazy. So that's a very interesting topic altogether. And if you take engineering physics, MSc physics or MSc chemistry, I'm pretty sure you will learn all of this in detail. The entire PDF of today's lecture will be available to you in the Telegram channel. And if you have loved today's session, do not forget to smash the like and also hit the subscribe button. Here is your homework question for today. Your first homework question, make sure you solve it and drop a comment in the comment section below. This is your second homework question, and this is your third homework question, and this is your fourth homework question, and this is your fifth homework question. So 5 questions. You get assignments for free on this channel. That's very good. But if you want more lectures, you want more one-shots, you want more recorded classes with PDFs, with test series, we have it just for you. Don't wait for the JEE announcement to happen. Make sure you make the best use of whatever courses Vedantu has to offer to you on the platform. Make use of YouTube. Watch whatever channel you like, but also study in the regular batch, because just from YouTube, you will not have that competitive spirit. You won't know where you stand. Plus that additional material, you just keep logging on, subscribing to so many, channels and probably subscriptions, but you will not have a dedicated flow. That systematic flow will not come. So make sure you make use of the Vedantu's crash course completely. And also you can check your percentiles, your scores right with your peers and also your seniors, so you know where you stand. Usually the course price is at 20,000, you get 50% off on it at 10,000. Since you are attending my class on JEE Enthuse and your favorite captain out here, so my coupon code right for you, SHHPRO, get 2,000 rupees off and you get the course for 8,000 bucks. If you're wondering where you can find the course, that's very simple too. So, okay, let me see if I can get my screen. If you're watching the YouTube video right now, what you need to do is just go into the description box right over here. Lots of courses out here for you, like the JEE crash course for the droppers. You have the CBSE term 2 preparation as well. You can see the CBSE term 2 preparation, mock tests, assignments, regular sessions, just for 5,400 bucks. Even you go for the higher package, best part, it's the same thing. So go for the higher one. You get doubt solving as well. Well, if you want the JEE crash course, there you go. Select your target exam, that's JEE 2022 crash course. You will get the best teachers in the country who have experience in training kids for the top ranks. Thousands of students have got 90 percentile and above last year alone, just from Vedantu. So make sure you make the best use of it. Choose any one of them. Both are English medium batches only. It's up to you. Now it says 9,000, but use the coupon code, and once you click on it, you will get more 1,000 rupees. Look at it, it becomes 8,000. Crazy. That's the advantage of using the coupon code right over there. So you have 3 packages, but in crash course, you don't have those separate divisions of doubt solving and all of that which you have in pro. You will get doubt solving, you will get assignments, you will get everything. All right, so make sure you avail this offer at the earliest. Please don't wait for the JEE announcement to happen. All right, so I'll be seeing you guys in the crash course. It will be lovely to have you over there so that I can see your percentiles boost up. And yeah, I want you guys on the screen next year, like your photographs and all of that. So let me just pull up the chat box as well. Thank you, welcome, bless you, Joseph. Then rather than giving, yes. So welcome, Ratingam. And I'm not sure about other websites. There might be a lot of institutes which give you material for even very cheap prices, but I don't know, I can't comment about other courses. They might be good, they might be bad. So it's up to you. You can try it out, and trust me on this, that you should also look at the history of the particular subscription, the particular institute that you're joining. Not just that, you should see what kind of features you're getting. A lot of students join some subscription or some crash course available at a very cheap rate, somewhere available online, but all you get is recorded classes. And that too, you get the recorded classes only for a limited time. These recorded classes are available till the 4th attempt, number 1. Number 2, the doubt solving and the mentorship happens till the end. Till the 4th attempt, we won't leave you in between. That's very important. Got it? So make sure you do your due diligence and research, because just don't go after money. Because if you go just after finding the cheapest course, I'm pretty sure you're going to find a lot of cheap courses than this. But the quality of service and the kind of benefits you're being offered will also be compromised. So make sure you get the best affordable course in your budget friendly pocket, so that you get the quality content and the quality service. That's what is very important. The first attempt Arya, hopefully, most likely it should have happened in March, but looks like it's going to get postponed to April or something like that. Welcome Riju, have a great time. Tentative, like I said, Bhunesh, that's what I'm expecting, March, or less likely now, maybe April now. Thank you Rohit so much. Okay. No problem, it's up to you, Anay Choksi, it's completely up to you. wherever you go, just make sure you are satisfied and you are happy. All right, have a great time. Bye bye, take care, hasta la vista. This was Captain Shreyas signing off.